Hello grade 11s and grade 12 that will be watching this video. Welcome to Analytical Geometry, something we did from grade 10, but we're going to quickly rebuild from grade 10 and then go on to grade 11 content. It's going to be quite fast and try to make it as brief as possible. We're looking at analytical geometry, which is also known as coordinate geometry, because we are looking at what we call coordinates. All right, let's start the whole lesson by first explaining what coordinates are. So we're looking at coordinates, introduction, the meaning of coordinates. So analytical geometry part 1, we're looking at coordinates. All right, this is basically, we call this a pair of points. All right, a pair of points on the Cartesian plane. That describes the location of a point. And usually this is what we will do. We'll write the point and then write the x first and the y first, and that's it. It is always the x first before the y. Okay, and while I'm here, it is important for me to quickly show you a few things, although I'm still going to mention them. So here's your Cartesian plane. This is known as your y-axis, and this is known as your x-axis. This is also known as your y, and the one on the left as your x. Don't forget, it is a positive on the right and negative on the left, positive above and negative below. Okay, very important now is to note that the equation of your y-axis is actually x equals to 0. Because if we calibrate this 1, 2, and 3, and negative 1, and negative 2, and negative 3, okay, here, negative 1, negative 2, and here positive 1 and positive 2. Okay, so you would see that that line, the y-axis, is actually, get a highlighter for you, it's actually a vertical line. And it's on the 0x value, so x equals to what? 0. However, if I draw a straight line that passes through 2, for example, I'm going to use 2 as an example, the equation of this line then becomes x is equal to negative 2. And if it's a vertical line, a quick point that we need to know is that this line would be parallel to that line. So that tells me that it is a vertical line. A vertical line. Also, another way to know that it's vertical is that this would be 90 degrees. It will be perpendicular because this is also perpendicular. So those, that is, sorry, x equals to 2, not negative 2. X equals to 2 there. Not negative 2, x equals to 2. If I were on the left hand side here, then I would have x equals to what? Negative 2, a vertical line. If I then go to the horizontal part, I'll start from my x-axis. At the x-axis, y is equal to what? 0. That's the equation of that line. And again, for me to draw a line, I would draw right a parallel line to the x-axis. All right, the equation of that line is y is equal to what? 2. These are horizontal lines, and I would consider them horizontal lines once I am given that this and this are parallel, or I am given that it is perpendicular to that, because properties of parallel lines, that we learned from Euclidean geometry. Again, if I were to draw that, it's important to quickly know these lines. Y will be equal to -2. Again, this is parallel. Let's put the signs on this one. This would be parallel and that. So I'm going to make this other one 3 lines or a single line. Let's make them single lines. So we have that, parallel, and that. So these are very important points that we need to talk about a Cartesian plane. Awesome. So that's just actually grade 10. That information is something we should be robust about from grade 10. Now we're going to jump into our analytical without wasting time. And the first thing I'm going to be looking at, actually, let me give you an idea, 6 concepts. All right, 6 concepts. So we start with number 1. Concept number 1 that we must know, and that is called gradient. We have an idea, so it's not going to be a new concept. We're just going to add a few things to it. Gradient, this describes the slope between 2 points. Between 2 points. So when I talk about slope, we talk about how steep 2 points can be. All right. It's the shortest distance, the longest distance between 2 points, rather. Okay, because that serves as your hypotenuse, basically. It is the hypotenuse. It is the hypotenuse between 2 points. All right. The hypotenuse. Once I say hypotenuse, you know right angle triangle will then be involved. Okay. Now, quickly, types of gradient. Types. There are 4 types that we're going to look at quickly. 4 types of gradient. A. So we don't use number 1 again. 4 types of gradient. I'm just going to draw them and write important things about them. Okay, those are the 4. This one is an increasing gradient. Because it's moving up as we move from left to right. Gradient here, the symbol for gradient is small letter m. Gradient here is positive. Now this gradient is greater than 0. The second one, decreasing gradient. Decreasing gradient, m is negative and m is less than 0. All right, now if we look at the third one, we're checking whether it's decreasing or increasing. Actually, this is an undefined gradient. We will see why this is undefined later. That is not a slope. It's a vertical line. So vertical lines have no gradient. Vertical lines have no gradient. We will see that when we start calculating the equation of a line again. Now here we have a 0 gradient. 0 gradient. M is equal to 0. So horizontal lines have 0 gradients. This is very important, especially for those of you doing physics as well. Okay, so those are the 4 points I have on my gradient. Very key. Please, let's make the writing very fast. I'm going to run now. Facts about gradient. Facts about gradient. facts about gradient. And here we'll be looking at how to calculate this thing called gradient. Number one, your gradient m is actually change in y over change in x. That is a measure between how your x value between 2 points are changing, your y values respect to what? The x values. How 2 points are changing. This is x. All right, let's call this x1, y1, x2, y2. Okay, please, this is very important. Don't mess it up. We always write it as 2 and 1, 2 and 1. You can also write 1 and 2. Okay, but I'll be showing you how I represent mine once we have letters. When we have letters, I no longer use the 1 and the 2. For clarity, I start using the letter of the particular point, and you would see. This we all know from grade, I think from grade 9, we were calculating gradient. Number 2, y equals to what? Mx plus c. So gradient is the coefficient. Gradient is the coefficient. All right, gradient is the coefficient of x. Coefficient of x. All right, in the equation of a line. In the equation of a line. But here, please, you must make sure that the equation is written as y. Example, if I tell you y equals to 3x plus 4, then your gradient will be equal to what? 3. What if I give you this? What if I give you this? 4 minus y minus 3 plus 3x, let's do this, equals to 0. And I ask for your gradient. Especially, let me add a 2 here. 4 minus 2y. 4 minus 2y. Don't be tempted to say your gradient is 3. No. Rewrite the whole equation first as y. So I'll have negative 2y equals to negative 3x, all right, minus 4. Then I'll divide across by negative 2. So negative 3x over negative 2 minus 4 over what? Negative 2. The negative divided by negative would give me positive, so I have 3 over 2x plus 4 divided by 2. My gradient, therefore, now is 3 over 2. So when you are given the equation of a line, gradient is the coefficient of x. Please make sure that it is written as an equation of a line before we talk about gradient. Number 3. Now, this is going to be new to us, using trigonometry. Using trigonometry. Tan theta is equal to m, where theta is the angle of inclination measured from the x-axis in an anti-clockwise dimension or direction. In an anti-clockwise direction. Please take note, it has to be anti-clockwise. All right. 2 points quickly. When the gradient is positive, theta is an acute angle, which means it lies in our first quadrant. Trigonometry is back. When the gradient is negative, I'll be doing quick examples here now. When the gradient is negative, theta is an obtuse angle. And that would be in the second quadrant. You remember that in the second quadrant, our tan is negative. That is, theta would then be between 90 and 180 degrees. Note, use your knowledge of reference what? Angle. Emphatically, let's spell it out. Do not use the sign when calculating reference angle. Then find theta by saying, remember tan is negative, theta equals to 180 minus the reference angle. This is very important so that we maintain what we learned on the trigonometry. Theta is 180 minus your reference angle. Please take note. Tan theta equals to, remember, theta is just the notation of the angle. It can be alpha, it can be beta, based on the number of angles an examiner wants you to measure. So where theta is the angle of inclination measured from the x-axis, let's put an hyphen there, all right, in an anticlockwise direction. That's trigonometry. When the gradient is positive, theta is acute. When the gradient is negative, theta will be obtuse. And then we use our knowledge of trigonometry. A quick example would be this. I'm sure you are done writing. If you are not done, please just pause the video. Beautiful. We have a lovely Cartesian plane there. Okay. Now I'm going to draw a few lines. There we go. And I'm going to draw that. So I have two lines. And you know what happens here is this. They would naturally then create a triangle here. Beautiful. That's beautiful. So let's call this point A, let's call this point B, and let's call this point C. Okay, so how do I measure the gradient of BC using theta? This I have to go anti-clockwise from the X. So let's call this theta. Okay, let's call this point E, and let's call this point F. All right. Now, what about point F, the gradient of AB? This would go anti-clockwise. All right? And let's call that beta so that we just create a difference between the two. Now, the important thing that you need to see here is this. An examiner will be asking you to, this is the common one, they'll be asking you to calculate alpha. But that's not our focus here. That you just used your normal geometry, all right, of triangles. But let's look at how to get theta and how to get beta. Remember, we are measuring anti-clockwise. I'm just going to create coordinates here. X is on the negative. Let's call it -2. Y is also on the negative. Let's call it -6. All right, point C. X, we're moving very far now, so let's call it a 6, and let's call Y a 3. Okay, and let's look at A. We're going to call A a -5, and we are above 3, so we're going to call it a 6, +6. Awesome. So there we go. How do we, first thing is to calculate the gradient of BC. So I'm going to do it on the side. Gradient of BC, I like to say YB minus YC. That helps me over X of B minus X of C. The reason I do this is from experience, so that we don't take the coordinate of B and write it for C when we write our 1 and 2. Okay, now what is the Y value of B? You see, it's now easy for me because I know that I'm dealing with B. Negative 6 minus, what is the Y value of C? Which will be what? 3. Over, what is the X value of C? See, I'm going back to my B coordinate. Negative 2 minus, what is the X coordinate of C? Oh, by the way, let's check. We know that this should be a positive answer, right? So be expectant. If you put this in a calculator, you're going to have minus 9 over minus 8, which will then give you 9 over 8. Be expectant about it. It is a positive gradient because of the way it looks. It's an increasing. That was the first type that we looked at. All right, now check. I want to then get theta. Then I'm going to reverse this whole situation. Okay, I will then say tan theta. Please, you have to measure and see which line. This is line BC. Okay, so I'd say tan theta equals to what? Gradient of which line? Because theta is connected to BC. So tan theta equals to 9 over 8. What is my theta? I will then be looking for the arctan of that. Then we would reverse the whole situation now. So arctan of what? 9 over 8. And what's the value? 48,37. 48,37 degrees. Beautiful. All right, 48,37 degrees. Sweet. Let's quickly calculate the one on the left. Gradient of AB, YA minus YB. Just make it simpler. XA. All right, we should have an expectation. We are going to get a negative gradient this time around. What is the Y value of A? 6. What is the Y value of B? Negative 6 over. Let's put that there. That gives me 12 already. Okay. What is the X value of A? Negative 5 minus, what is the X value of B? Negative 2. Okay, that gives me 6 plus 6 will give us what? 12 over 2 minus 5. Remember, that is minus, but use your calculator, but we can do this without. 2 minus 5 will give me negative 3. So my gradient is negative what? 4. Now, please watch this one. All right, now, let us get beta. Tan beta, we know the gradient of what? AB. That's the line we're looking at. So, tan beta is what? Negative 4. Now, this is where I say we are now looking for our angle. Do not use the, it's better to keep it the way we're doing it under what? Trigonometry, where we know that the negative tells us the quadrant. Is that okay? So I'll be looking for my reference angle, which is what? The arctan of 4. All right? The arctan of 4. And what would that be? Remember that we know it's in the second quadrant and it must be obtuse. But what is the arctan of 4? 75,96. This is very important. That's not theta. Now, what is theta? We know it's in the second quadrant. So that we keep the same system of calculation, whether in trigs or in analytical, because we are using trigs. So 96, check. That angle is 104,04. Beautiful. 104, what? 04 degrees. That is very important. So our angle is 104. All right. Remember, trig, we move anti-clockwise. Now, your 75,96, I want to show you where that angle is. We move anti-clockwise. If I start moving clockwise, check this, angle on a straight line, then I'll be getting this because I used a positive to find the reference angle. Do you see that? if I say 180 minus 04,04, I'll get that 75,96. Oh, I don't know if that makes sense. Reference angle, we do not use the sign because we are in the second quadrant. Then we say 180 minus that. I hope that makes sense. I hope everybody's good there. 180 minus. The positive is just the change in direction, but usually we move anti-clockwise. I hope that makes sense, everybody. And from here, if you were given the angle, I'm sure we can walk through. The angle here is 48, what? 37. If I were to find the gradient given the angle, I'm sure that is something we can all quickly do. It's just to look for gradients. We can do that on the side here. Don't have to move. All right. If I'm given theta is 48,37, and I have to look for the gradient, I know that tan theta equals to gradient of what? BC. What would that be? Gradient of BC, therefore, would be equal to the tan of that angle. There's no two-way about that. Put that in a calculator and you are done. I'm sure you're going to get 1 point something here. Tan 48. Yeah, because tan 45 is 1,37. That will give you 1,125, which is 1,13. Done. And the same thing applies here. Beta, tan beta will be equal to gradient of what? AB. And we already know our angle, tan 104,04. So what's going to be our gradient? I'm going to show you something on the right hand side, just quickly. On the left hand side, what do we have? Tan 104, because we've rounded up, you'd see what it's going to look like. You see, negative 3,998, which is negative what? 4. 998, two decimal places would give us negative 4. On the right hand side, our initial gradient was 9 over 8, just to show you that. Was 9 over 8. Let me do something here quickly. Yeah, let's move it to the side. Keep your eyes on the right hand side. The gradient we got in fraction was 9 over 8. And if we change it into decimal, can you see 1,125, which is 1,13. I hope we're good. Awesome. All right. This is very, very important. Now, how do we get that angle alpha? This is the major thing that is new in grade 11. Now we can use our knowledge of Euclidean geometry on any geometry of triangles. Geometry of triangles. I want to calculate angle alpha. How do I get angle alpha? We could use sum of angles in a triangle, or we could use exterior angle is equal to opposite, sum of opposite interior what? Angle. Check this. I am now looking for alpha. And if I check, I've got a triangle here. I am not going to be looking at the entire triangle. Check this. Let me make it thicker. I am only going to be looking at this particular triangle where I have the angles. Do you see that? I am now, so I could do this in two ways. I know this is vertically opposite. 48, what? 37 degrees. Oh, then I know that this plus that should be equal to 180. So 75,96 plus 48,37 plus alpha should be equal to what? 180. All right, this is one way, and we get our alpha. Let's just quickly do that calculation together quickly. It will be 180 minus 75,96, taking both to the other side, 48, what? 37. 55,67. degrees. Or I should know that, what's this one? This angle plus this angle should give me the exterior. All right, I'm sure you still remember our exterior story. The exterior, we need to know that. That's very important. Exterior. Okay, so we can say alpha plus 48,37 equals to what? 104,04 degrees. The inner angle here, where's my highlighter so that we see? The angle here plus the angle here, exterior is 104. That's an extended line. Exterior angle is equal to sum of the opposite interior angles. What is my alpha going to be? Let's just use a calculator and we move on to our next concept. 104,04 minus 48,37. Exactly 55,67. Done. 55,67 degrees. So this is what analytical will do, bring in a whole lot of concepts in one question. We're going to use trigs. In some cases, we're even going to use cosine rule, sine rule. All of those are applicable. Math is not isolated. All right. So that is our concept number 3, which is new in grade 11. But not entirely new because we've done trigonometry. Sweet. Good. Beautiful. Let's look at number 4. Again, what was our fact? Number 1, m gradient, y equals to y2 minus y1. Number 2, y equals to mx plus c. And number 3, tan theta equals to m, angle of inclination. Okay, number 4. Number 4, parallel lines. And here we know the story. All right, if two lines are parallel, then their gradients are equal. Parallel lines have equal gradients. Parallel lines have equal gradients. Parallel lines have equal gradients. So if this line is parallel to that line, A, B, C, and D, then we know that the gradient of AB is the same as the gradient of what? CD. Please make sure that your AB is, your letters are subscript and not as big as the M. And please, the M is a small letter m. That we are done. Number 5. Okay. Number 5. Perpendicular lines. Perpendicular lines. All right. If two lines are perpendicular, the product of their gradient, gradients will be equal to -1. So we have that, right? A, B, C, and D. So we're saying gradient of AB times the gradient of CD should be equal to -1. And you don't have to do all the maths, all right? Given gradient of AB, all right, we can find the gradient of CD by changing the sign and reciprocating the number. Change the sign of gradient of AB and reciprocating it. Reciprocating. You don't have to really do all the maths. E.g., if the gradient of AB is 2, and we know that AB is perpendicular to CD, then the gradient of CD, now that one is a positive, right? Let's make this a negative. Negative, right? And then we reciprocate. It is 2 over 1. This one becomes what? 1 over 2. And we're done. Even if you are given the gradient of CD, so we just change the sign. All right? Given that the gradient of CD equals to negative half, and you know that CD is perpendicular to AB, then gradient of AB, what do? That one is a negative, we make it a positive, right? 1 over 2, we reciprocate 2 over 1, and then we are done. You don't need to do all the calculations. So if an examiner then says, prove that 2 lines are perpendicular, what do? We find the gradient, multiply. If it then gives us negative 1, then we know that those lines are perpendicular. Let's just put that quick note down. To prove that lines are perpendicular, find the gradient of both lines, multiply them. If their product is negative 1, then this sounds like converse. Our lines are then the lines are perpendicular. Lines are perpendicular. Wow, we're still looking at gradient. Okay. Interesting. We're going to look at 6. We have 7, like I said. 7 points on gradients that we need to look at. So we have 2 more. This information we already had from grade 10. So I'm going to make these lessons into 2. So lesson 1 will just end on gradients, and lesson 2 we put all the other concepts together. Then lesson 3 we jump straight into activities. Okay, point number 6 now. You may pause the video if you need to write. Point number 6, still on gradient. Collinear points. Collinear points. All right, these are points on a straight line. Now, the gradient between any 2 collinear points are equal. What do I mean? Collinear points are points on a straight line. So if I have point A, point B, point C, and point D, we can see that these points are collinear. They exist together, linear, together, linear, straight line. We are simply saying the gradient of AB will be the same gradient as BC. Oh, this would actually be the same gradient between C and D. Oh, this would be the gradient between A and C. This will also be the gradient of B to D. This will also be the gradient of A to D. All right, any 2 points, AC, BC, BD, CD, any 2 points on this line will maintain the gradient of the other 2 points. The gradient between any 2 pairs of collinear points are equal. And that's just it. That's number 6. Let's look at number 7 quickly. Number 7 is more of an application. All right. It's more of an application. Gradient by transition. Gradient by transition. Gradient by transition. These exist when lines are parallel on both ends. Show you what I mean. On both ends. So basically, we're talking about a parallelogram. I'd like you to please listen to this part very carefully. We're looking at a parallelogram, and I'll be dealing with the transition. Let me draw a quick parallelogram for us. Okay, now. There we go. A parallelogram. So we're looking at both ends. Let me do it like that. Okay. And okay, let me put it in my my coordinate first. Let me get my coordinate so that it looks easy for everyone to relate with. And here I wouldn't be doing any calculation. I'm just going to be looking at the movement. Awesome. Let's have it like that. Okay, let me just draw something here. Let me use my hands just to draw. This is wasting my time today. Okay, so I wanted something that looks like that. All right. And something that looks like that. Beautiful. Okay. I'm just going to shift my x-axis a little bit. Awesome. That's what I'm looking for. And I have that, and I have that. All right, what I'm going to do here happens on a parallelogram. Okay, so let's call this A, B, and please, when we label in that order. -1 and -4. Let's have this as 4 and -2. Let's look at B and have B as 3 and 5. Now, the question is, what is the X value of C and the Y value of C? This is the last point I'm looking at in this particular lesson, so we've dedicated this lesson just for gradients. I need to find, okay, there are so many ways of getting this. So many ways. I could use midpoint. There are about 4 ways. I could use midpoint. I could use distance formula. I could use the point of intersection of 2 lines, that is point C, and use the equation of the lines. But I want to use transition. And this would actually help you understand what gradient is. Now, when we say gradient of parallel lines, we're basically saying that the ratio of change on the Y is the same as the ratio of change on the X. Sorry, the ratio of change, all right, of Y with respect to X on one line is the same as the other line. Let's speak English now. That's something else. Between A and B, the line is increasing, all right, between A and B. Between C and D, the line is also increasing. Right. Left hand side, so that it's kind of easy for everyone. Now, this is what we do. We are going to check our transition quickly. What is the movement between A and B And then we compare that to C and D. All right, look at this. Look at my point A. This is what I'll explain this way, gradient. Check this. If I were to draw a point here between A and B, you don't have to do this, but it will help us see. Check this. Between A and B. Because these lines are parallel, A, B, and C, D, this movement will also be the same. And that's the whole idea. Our gradients are equal. It means the vertical shift and the horizontal shift are the same. Let's look at the vertical shift quickly. And the horizontal shift. Look at A, -1, right? Let me use a highlighter so you to see that. -1. That's the x value of A. And the x value of B is 3. That means here, what I have here, x value, let me use a yellow because it's not given. The x value is 3. Can you see that? Because it's a straight line, right? How many units have we moved? To get your number of units, you can just say right minus left. 3 minus -1. It means I have moved 4 units. You said the right minus the left. Remember, it was -1 here. Move here 1 unit. And then we have 3 units here. 1, 2, 3. That makes it 4. Look at what I'm going to do. I am going to go to D and move the exact same 4 units. So right now, my x value is 4. Oh, so I am moving 4 units. The x value here would be 8, which means my x is already 8, and I'm done. And we're going to confirm this. Again, I'll repeat. Let me repeat that. That's very interesting. From -1 to 3, because that's the x value there. I have moved how many units? 4. I have to move the same 4 units here. 4, 5, 6, 7, 8. We just add 4 units to the right. That gives me 8. So my x value is 8. What about the y value? What is my y value at this point? My y value is -4, because that's the point I'm looking at, right? We said, okay, there we go. My y value is -4. Write that in yellow, -4. Now I am going to compare my movement between 4 and 5. I'm actually going up. Here, I was moving right. I moved right 4 units. I have to move right 4 units. Now, from -4, how many units am I moving? We say top minus the bottom. It is 5 minus -4. That gives me 9 units upwards. Because the gradient is the same, the ratio of change in y and that of x, I should be moving 9 units here. All right. Going 9 units upward, what is -2 plus 9? That would give me 7. So the coordinate of C is 8 and 7, and I'm done. Please, I don't know if that makes sense to us. This point here is -2. If I move 9 units up, then I'll get 7. 9 minus 2 will be 7. Let's confirm if this is correct in terms of the gradient. Then I'll show you the other one. I can also move from A to D. Let's quickly find the gradient of AB. Just want to confirm if we are correct, which will be what? YA minus YB over XA minus what? XB. What is the Y value of A? -4 minus, what's the Y value of B? 5. Guys, we must get a positive answer. What is the X value of A? -1 minus the X value of B, 3. Okay, well, this gives us minus 9 over minus 4. Oh, this is 9 over 4. Let's check with what we did. I'll re-explain again. The gradient of CD, YC minus YD over XC minus xd. What is the y value of c that we got? 7. What is the y value of d? Negative 2. All right, that's my 9 already there. What is, and if you see, gradient is actually the shift. We got 9 and 4. All right, what is the x value of c? X value of c is 8 minus, what is the x value of d? 4. Can you see that? 9 over 4. Perfect. Look at the gradient. That gradient is simply 9 over 4. The change in y, which is the same change in y, change in x, which is the same change in x. So what I said was, we check the movement. I look at A and I look at B, the x value. From -1, I'm moving 4 units. How did I get the 4? So I'm comparing x here and x here. 3, the right minus left. All right, horizontal. To get the horizontal, right minus left. Because we're moving to the right, we're shifting to the right. Right minus left. 3 minus minus 1 would give me what? 4. And then I came here and did the same. 4. All right? Do you see right minus left? 8 minus 4 will also give me 4. So I can just add 4 plus 4, 8. Then I looked here. I have a -4 for y and 5 for b. I'm going up. How do I do that? Top minus bottom. Vertical, top minus bottom. 5 minus minus 4 would give me 9. Oh, so I know I'm shifting up by 9 units. All right, so -2 plus 9 would give me what? 7. I quickly want to do something for you. Here I used A and B. My last slide for the day, I want to use C and D, just to show us that we could use any 2 pairs. All right, so we don't have this, remember. I'm basically removing what I wrote, just looking at the question. Which one was missing? All of these were missing. Okay, beautiful. And in terms of the lines, I didn't have that. All right, this wasn't there, this wasn't there, was not there, 8 and 7 not there. Sweet. Okay. At first, I used the vertical lines. Now, I want to use my horizontal lines. Okay, let's check this. I want to work between A and D. Again, as a way of explanation, I'm working between A and D. So I'm going to draw my 90 degrees right between A and D. Do you see that? Which gives me the same 90 degrees between B and C. The first one I used A and B. Now I'm using what? A and D. Let's check. What is the x value here of D? It's 4. Interesting. And what is the y value? The y value is -4. All right, I'm choosing this y value because the horizontal line, and I'm choosing the x value. Where's my highlighter? X value, all right, remember, and the y value from there. What is my movement like? Quickly. From -1 to 4, we said horizontal, right minus left, 4 minus -1. This time around, I am doing 5 shifts. Using A and D, 5 shifts to the right. I must also come up here and do my 5. 3 plus 5 would give me what? 8. Oh, that's the same 8 that we got. Now it looks better. After the second explanation, I think. Now let's look at the y movement. What is my y here? My y here is -4. All right. And the y here is what? -2. Okay. So how did I move from -4 to -2? Top minus bottom. -2 minus -4. That gives me what? 4 minus, that gives me 2. So this is 2 units. So the distance between A and D vertically is 2 units. I must also move 2 units. What is my y value here? My y value here, okay, I shouldn't write my 8 here, sorry. My 8 should actually be here. Now, again, 2 units. Remember what the coordinate of this point is. We said, okay, my 8 is still fine there. Lovely. But what is the coordinate of this point on the y? It's 5. But now I've got to go 2 units up to get to C. 2 units up means I'm moving up 5 to 6, 1 unit, then to 7. Oh, beautiful. I have that gradient again, 8 to 7. Let's try to confirm the story of the gradients. The gradients must be parallel. So what's the gradient of BC? Okay, we said it is YB minus YC over XB. I like the letters. Makes life a lot easier for me. So I'm going to look at, when I say YB, I go to B and check the value of Y, 5, minus. I go to C and check the value. It's going to be what? 7. That actually gives me that 2 there. What is the X value of B? X value of B is 3. And what is the X value of C? That actually gives me 8, which gives me negative 2 over negative 5. And that gives me 2 over 5. Do you see that? It's about the shift. The vertical shift is 2, and the horizontal shift is 5. Vertical and horizontal. And already you see it's 2 and 5 again. Gradient of AD. As I round off the lesson now, would be what? YA minus YD over XA minus XD. What is the Y value of A? It's very easy now. Negative 4 minus, what is the Y value of D? Negative 2. Put that in bracket. Over, what is the X value of A? Negative 1 minus the X value of D would be what? 4. 2 minus 4 would give us what? Negative 2 and over negative 5. What's your answer? 2 over 5. Gradient by transition. But this exists between parallel lines on both ends. This is the easiest way of finding. It's 2 marks, by the way. And I'll be showing you with the same coordinates when we, in our next session, using point of intersection, gradient formula, calculating gradient, calculating distance, when I look at the properties of a parallelogram. So I'm going to come back to this question, crop it up, and use it, and show you that we can get the coordinate of C in different ways, but this remains the shortest as long as I have a parallelogram. And somebody said, how do we write down this answer? So this is what I'm going to say. For D, or from A to D, all right, it is going to be X plus 5 units. All right, X plus 5 units. So it's X plus the shift. And that gives me my X. And for the Y, all right, it's going to be what? Y plus what? 2 units. And that gives me the coordinate of D. I hope that makes sense. X and Y. So to write it, you would see us doing this. X plus 5, no, D, not A now. X plus 5, and then Y plus 2. That's the transition. X plus 5 and Y plus 2. Let's do the same for this one. What will it be? For the X, so our coordinate of, so this means, sorry, let me go back quickly. Let me just complete something here. All right, therefore, the coordinate of C will also be what? This is from A, XA plus 5, YA plus 2. XB, we keep the same, plus 5. And YB plus what? 2. Because now I'm moving from B to C. I hope that makes sense. From A to D, I had to do that. A plus 5 units will give me D. Y plus 2 units will give me D. So for B, B plus 5 units will give me C. And B plus 2 units would give me the Y value of C. So here, what should I have written? Just added to it. D is XA, we moved 4 units, right? Plus 4. And y, we moved how many units up? 9. Beautiful. Therefore, we can say the coordinate of C will be xb. No, here we used A and B, sorry. Here we used A and B. A to B. The coordinate of B would be xa plus 4 and ya plus 9. Now from D to C will be what? xd plus 4 and yd plus 9. Perfect. xd plus 4, we moved 4 units to the right and 9 units up. And the same would have happened if we were moving down to be minus and left would be negative. We'll do a few more examples of this, but I hope it's clear. It's gradient by transition. Awesome. All right, this would be the end of lesson 1. The end of lesson 1. We will then go into lesson 2, looking at the other aspect of analytical, where we talk about things we know: distance, midpoint, the point of intersection, properties of parallelogram, and then we look at activities in that lesson. All right, thank you guys. I hope you enjoyed lesson 1. Please watch over and over again. Even you are in grade 12, we use the same concept in dealing with analytical geometry. Goodbye. Catch you in lesson 2.